here I'm going to define the method. So in the return type is int, and the method name is linear search. And for this, the input is like array, input array. So for this method, like the first parameter is array, and the second parameter is like a search element. Here's like this ID will show the errors, like why they showing the error right here. Basically, like in Java, for everything we need to create the objects. So if you want if you want to use the methods without creating the objects, then we can use a static. All these topics like we'll cover in Java. Just like here we are focusing on the linear search part. Yeah, if you see this method, we have two parameters, input parameters. One is array and the search element. First thing, like in algorithm, we need to check for the null checks whether the input is really exist or not. So first thing, like we'll say if array equal to null, meaning the given array is null for this method. So here we'll return -1. So in array, like index starts from 0, it won't start with the negative values. So we'll return -1. And now the array is not null and it really exists in the memory and it has the values. Now, like for we need to iterate the array, and now like we need to check we need to compare the elements one by one. Now for the first time in the for loop, the element will be 0. So we're going to check if array of index equal to search element. So what will happen, like for the first time we're going to compare like is 10 equal to 70? No, then it won't go to the inside if loop. It will go to the index plus plus and it will do the condition check, and for the second time it will check again like is 20 equal to 70. It's like 10 equal to 70 first the first time, second time 20 equal to 70. In the same way it will continue. Finally it it's end up with 70 equal to 70. Then it will enter into the if loop. Here like we are returning the index, so everything after after any statements of return, right, it won't execute. Now, still this method is showing error. Why? Because like we have a return statement in two places. One is here. So when this line executed, if the array is none, then it will come here. And the second return statement is here. So when this will be executed, if the if statement if this condition is passed, then only it will enter into here. So for example, if the search element does not exist in the array, right? So this function accepts always to return. So here we'll say -1. Whenever we write any algorithm, right? So first thing uh, we need to code it. Then we need to do the dry run. Dry run is very important to check like whether the algorithm will solve or not. So dry run is like nothing like just like taking first, for example, okay, how the execution job will happen. So first it will come to the main method. Okay, yeah, this fourth line is empty. Then fifth line will come. Okay, here it's initialize the array with 10, length 10. Okay, so now array is initialized with 10 elements. So size is 10 with all the zero values first by default, right? And the second, and for example, the sixth line. Now we're initializing the array value. We are reinitializing the first element with 10 value. So again, here it's going to be 10. In the same in seventh line, we're initializing the second element with 20. So till 15 values, we are assigning the values to the array. So for example, if you take the steps as line numbers, right? So here till step 15, we just initialize the array, but we can say like step 1. Step 1 just we initialize the array with the elements. And now in step 2, we're calling a method, linear search, by passing two values. So step 2, we're calling linear search method with two input values. array and 17, right? And now, since like we are calling the method, the execution will directly jump into the 23rd line. So now it will come here. And now here we're checking a null condition. So in step 3, we are checking array equal to null, which is not true. So false. So what will happen? Like it will directly come to the for loop. So step 4, for loop execution. So step 5, like we are going to assign the index to 0. Step 6, for loop condition check. So we are going to check like index is less than the array dot length, which is like 0 less than 10. Condition is passed, so it will come inside the for loop. So line number 28 will be executed. So step 7, like we are going to check whether the array of 0 is equal to 70. So this will be false. So it won't enter into the if condition. So directly it will go to the incremental part in for loop. So step 8, we are going to increment the index value, which is like a index plus 1, index equal to index plus 1. So the previous index value is 0, and we are going to increment with 1. So the final value will be 1. Again, it will come to the step 6. It will check like 1 less than 10. Again, it will come to step 7. Now it will checking, he's going to check with second value, which is like 20 equal to 70, which is false. In the same way, like we are going to, instead of running the algorithm, right, we define the dry run. So we'll see like what each line is doing, and we'll make a note like this, right? So like instead of computer going to say whether this algorithm is going to work or not, we are going to say in whom, and like we are going to we are making the dry run, and we are going to judge our algorithm is really working or not. And coming to the time complexity, like the question is like how much time it's going to take to execute a linear search algorithm. What's the time complexity for the linear search algorithm? So here, like we have like n elements. So here the n equal to 2, n equal to 10. N is like size of the array. And now to search an element in the array, we need to iterate each and every element. For example, if we are going to search the 10th element, 10th value, right? So it is in the first index itself. Uh, s- so the array is not going to execute all the elements. So whenever it comes like index is 0, it's going to say, yeah, I got the element, so it's going to return. So the rest of the, like we are not going to iterate the rest of the part, rest of the array. But as I said you, like in computer science, we always consider big O as a worst case. So here the best case is like if the element, like the search element is the first index, right? So only time complexity will be order of 1. The search element is in the first index, but that's not right. For example, if you're going to search like a 1110 element, which is not exist in the array, we need to iterate each and every value of the array. So we need to iterate all the size. So here we're going to iterate order of n. So order of n means like we need to iterate entire array to check if the element exists or not. So the time complexity of linear search algorithm is like order of n. N is the size of the array. So the array. Yeah. This is like linear search algorithm. That's it. Very simple algorithm, right? And now it seems like we need to iterate each and every element to find the given element, right? So it's like order of n complexity, which is not going to work in the real time. And so something it should be better than that. Like if we have 1 million records, we can't search the 1 million records, right, to find something. Like we have 1 million records of names. For example, some website, for example, like if you take any Flipkart or something, they will have like a millions of users, and when the customer is logging, we can't check his name against entire database. There should be some algorithm to validate whether the user is exists in the database or not with best time complexity. So I can explain, like I can I'm going to give like a binary search algorithm. Just I'll copy these things. Now we have seen the linear search. Now we are going like we have seen the linear search. You can see the binary search now. And why binary search? And we can going to check whether binary search is good or linear search is good. Mm, So just like to retrieve the error, right? By default, like we'll say return -1. Yeah. Now we can't see any errors in this. Binary search. So here the name itself saying something we are doing binary means like we're dividing something. Here one thing like for binary search. So binary search also is one of the algorithm. As I told you, like algorithm is like some defined steps. So like if you want to solve something in this algorithm, right? Some binary search algorithm. So binary search algorithm will have predefined steps. So binary search algorithm will say to execute any problem in binary search, the first step is like that. The first step should be it should be sorted. So like if you want to solve any kind of problem using binary search algorithm, so first thing we need to keep in mind, okay, if you want to use binary search, then the input should be sorted. Then only we can use the binary search. Otherwise, the binary search algorithm won't suit to solve the problem. So whenever like if someone says binary search, first thing to keep in mind, the data like the input should be sorted. So binary search algorithm is not going to work on the input which is not sorted, which is going to explain the next steps. Yeah, it should be sorted. So we'll go and check whether the input array is sorted or not. Yeah, it is sorted. It's like it's sorted like from increasing order. It's like 10, 20 is incremental order, right? So it's sorted. Fine. And binary search, since it is sorted, it's going to use some predefined steps. So first we need to divide, second step, divide the array. So divide the array in the sense not like dividing the entire array, just like we need to create an index. We can say like mid value. Yeah, mid index equal to length by 2, which is like 10 by 2, 5. So the mid index is 5. So binary search first thing, array should be sorted. Second thing, we need to find the mid index value. So here the mid value is 5. And now we are going to see what is the mid value like array of 5. 1, 2, 3, 4, 50, right? So the mid value is 50. And now we are going to say, we are going to check. For example, step 4. Yeah. Now we are going to see whether 50 is greater than or less than of the search element. Here we like the search element is 17, right? And now we need to check whether the 50 is greater or less than. Here if you see 50 is less than the search element, 50 is less than 70. So this means we are going to divide the array. So the search element exists in the second half, not in the first half. So in binary search, what happens for the first time itself, it's going to say, okay, whether I need to search the second half or first half. Now since yeah, we need to search since 50 is less than 70, we need to search in this portion. Now the array is divided. So we're going to search only in these elements, not in the remaining the first half. Again, we need to find the mid value. Same, the step 3 will be executed. Again, we need to find the mid index. So here, how many elements are there? 0, 1, 2, 3, 4, 5, 6. 6 elements. 6 by 2, 3. Now array of third index is 17. Now it's going to check whether the such element 70 is less than or greater than or equal. Now the 70 is equal, so it will return the value. Yeah. So for binary search, these are the steps we need to follow. For the first thing we need to keep in mind, it should be sorted. And the second step, we need to find the mid element, and then we need to find the mid element. And the third step, we need to check whether such element is less than or greater than to the mid value. If it is less than the such element, right, then we need to look into the second half. If not, then we need to look into the first half. Again, we need to find the mid value. So all the steps are repeated. Okay, so just I'm going to code it here. So as I said, first thing, always we need to check whether the input is really exist or not. If it's not exist, straight away return it one. No need to check everything, right? Now for the final search, we need to take three values: int low, int mid is equal to array dot length by 2, int high maximum length. So here we define three variables low, mid, high. For binary search, we can use while loop, do while. I'm going to use a while loop. So first thing, we need to check whether the low should always be less than high. This is the base condition. It means mm, we are not doing the same uh, like we arrived the second stage, second part of the array. Again, we are not going to be the first part array. So to break the condition, it's always low into high. And now we can calculate mid here itself by using low plus high by 2. Yeah. And now we are going to check is array of mid equal to the search element. If yes, return mid. If no, then we need to check whether this search element exists in the first half or second half. Here, for example, array of the mid is 50 and the value is 17. So which means the search element is going to exist in the second part of the array. So what we are going to do, we are going to reassign the values. So we are going to say low equal to mid. That's it. And for example, if the search element is 10, 50 less than 10, which is false, right? So it will come to else part. Here, what we're going to say, high equal to mid. So we are playing around with the index value and we are not like dividing the array, just like we're changing the values. That's it. This is like a binary search and we can do the try run. So I'm going directly going to jump into here. So we are assigning the low value step one. We assign low equal to 0, then high equal to array dot length, which is 10. Cool. And okay, we didn't define the mid. Okay, so now in step second, we're going to say whether low is less than high, which is true. So it will enter into the while loop. Step three. Now we're like we assign the mid value to low plus high mid by 2, right? So low plus high by 2, which is like a 10 by 2, 5. So the mid value is 5, and we are going to check whether the mid is like say the element which we are searching. Step 3 is array of mid equal to search element. So mid is 5, so array of 5 equal and search value is 70, which is false. So it won't go to the if loop, if statement, and it came to 60. This is step 4. Step 5, we were checking whether the mid value is less than the search element or not, which means like 57, which is true. So step 6, we change the values. So what we said, low equal to mid. Now low is become 5, right? And now again, like it's going to the step 2. Whether low is less than high, yes. 5 less than 10, true. And now like it's going to the step 4 again. Sorry, step 3. We're going to calculate the mid value. Here low is 5. 5 plus 10, 15. 15 by 2, which is 7. So now mid is 7. And now like we're going to check step 4 will be repeated again. So array of mid like 7. So what the value of 7? We'll copy here. So it will be better. Now 1, 2, 3, 4, 5, 6, 7. 17, which is true. Now it's going to enter the if statement and return mid. Return 7. So this is the binary search. So here like we're not iterating the entire array. We're dividing the array into 2 and we're checking the mid value which is less or greater than, and just like we're iterating the same. So here the time complexity is we are dividing the first time we are dividing the half, and second time we're dividing like 4 by 2, like n by 2 for the first time, then the second time n by 4, and third time n by 8. So it keep on like, yeah, it will keep on continue. So the time complexity is like a login. N is the length of the array.